This is integration, and this is our third lesson, which is we are referring to as area under a curve. So we are going to learn how to calculate area under a curve or a graph using the integration method. You can advertise here. Just call us on 0725 35 7594. Thank you. Welcome to this lesson in the topic integration. In this lesson, we are going to look at the area under a curve. So the exact area under a curve, a graph or a curve, is worked out by integrating the function within the given limits. So we are going to look at a few examples and see how it is done. So in this example, we want to find the area under the curve or the shaded area. That is part A and part B. We'll use the first method to find the area by getting the area of the rectangle and we add to the area of the triangle. So the area of the rectangle we get, it is length times width. So area is equals to, length is 1, 2, 3, 4. So it is 4 multiplied by 3, which is the width, that is from here to there. Then the area of the rectangle, we say it is a half base times height. So we write a half. Our base is 4 and our height is 8. So we get this 4 times 3, you get 12, plus 4 divided by 2 is 2. So we have 1. So 2 times 8, we get 16. And when you add 12 to 16, you get 28 square units. So that is the ordinary method that we would use. Now we are going to apply the integration method and see whether we still get the same area. So using integration area, we are required to find the area under the graph. Our limit are 1 and 5. So we integrate area is equals to the integral from 1 to 5 of 2x plus 1 into bracket dx. So when you integrate this, you should get x squared, because we will divide by 2, the 2 will disappear, plus x into bracket 1 to 5. And when you substitute this, you get, we substitute 5 for x, so we get 5 squared plus 5 into bracket minus, now here we will have 1 squared is 1 plus 1. So this will give you 25 plus 5 is 30. So this is 30 minus 1 plus 1 is 2. So we get 28. This implies area is equals to 28 square units. And remember, we had in our first method, we got the same area. This, in conclusion, we can say that we can use we use integration to find the area under a graph. We use integration to find the area under a graph, as we have seen that the two areas are the same. Or when we use different methods, the integration method and the ordinary method, we are getting the same area. This shows that integration method will give us an exact area under a curve. You can advertise here. Just call us on 0725 35 7594. Thank you. So in our example 1, find the area under the curve y is equals to x squared from x is equals to 1 to x is equals to 5. So we had plotted this graph area and approximated the area. You don't need to draw the graph each time you are required to find the area. You only need to use the limit and integrate. But for the sake of just reminding ourselves how the graph looks like, let's have a look at the graph we had plotted earlier on. So this is how the graph of this function looks like, and we are required to find the area from x is equals to 1 to x is equals to 5. So when we approximated the area using the trapezium method, we could not get the exact area. But when you use integration method, you are able to get the exact area under the curve or the area shaded. So we are going to integrate x squared with respect to dx from 1 to 5. So this is supposed to give us the area. Once you integrate, then you should get, this is x cubed divided by 3. We put the brackets and our limits are from 1 to 5. Now from there we substitute x for 5, so you have 5 cubed divided by 3 minus, we substitute x for 1, so x cubed is the same as 1 divided by 3. So this will give us, this is 125 over 3 minus a third, and that should give us 124 divided by 3. So this is area, and you can also write it as 41. That is, we divide by 3 and a third square unit. So this is the exact area that is under the graph. So we can say that with the integration method, we are able to get the exact area under the graph, unlike the other method we had used earlier, that is a trapezium and trapezoidal method in area approximation. You can advertise here. Just call us on 0725 357594. Thank you. So in this example 2, find the area of the shaded part of the graph of the function y is equals to x squared minus x minus 6. So this is the area shaded in green. Our limit will be from minus 2 to 3, and therefore when we integrate, we will be able to get the area is equals to the integral from minus 2 to 3 of x squared minus x minus 6 close a bracket with respect to x. So when you integrate this, you will be able to get into bracket x cubed divided by 3 minus x squared divided by 2, and then we have minus 6x, and our limits are from minus 2 to 3. So we substitute the value of 3 in place of x. We will have, this is 3 cubed divided by 3, we put the bracket, minus 3 squared divided by 2 minus 6 multiplied by 3 close the bracket, minus, we substitute minus 2 in place of x. So here we will have minus 2 cubed divided by 3 minus 2 into bracket squared divided by 2 minus 6 multiplied by minus 2, and we close our bracket. So from this side, this will be 9 divided by, this is 27 divided by 3. we will get 9 minus, this is 9 divided by 2, we get 4.5 minus 18, close the bracket. This is minus. Now this will be minus, this minus 2 cubed is minus 8 divided by 3. This will be plus, so we have the minus sign remains, so this will be 4 divided by 2. We get 2, and this is plus. This changes to plus because of the 2 minus 6 and minus 2, so we have plus 12. Then we can now get our area. When you 9 minus 4.5 minus 18, you will be able to get minus 13.5 minus, this will give you 7 and a third, which gives you minus 20 and 5 over 6. Now this is the area, but our area cannot be negative. Area cannot be negative because it is a quantity. The negative is appearing because the area is under the x-axis or in the negative side of y, and therefore the area is equals to 20 and 5 over 6 square units. We ignore the minus sign and get the area, or put the area to be positive. So that's how you get the area shaded. So whenever the area area that we're looking for is under the x-axis or the negative side of the y-axis, you always find that the area will be negative, so ignore the negative sign to get the actual area. You can advertise here. Just call us on 0725 357594. Thank you. So in our example 3, find the area of the shaded part. Now here we have a graph or a curve, which is y is equals to x cubed divided by 2 minus x squared over 2, and then plus x over 2. So one area, that is A, is under the x-axis, and therefore that area, when we integrate, you get a negative, and the other area is above the x-axis. So we require to work out each individual area and then we add. So we start with A. So area 1 is equals to, we integrate the function. The limits are from minus 2 to 0. So we put minus 2 there to 0, and then our function is x cubed divided by 3, x cubed divided by 2 minus x squared divided by 2 again, and then plus x divided by 2. This is with respect to dx, with respect to x. So when you integrate that, you get this is equals to x to power 4 divided by, now when you divide 2 multiplied by 4, you get 8, and then we have minus, this is x cubed, and then 2 times 3, you get 6, plus this will be x squared divided by 2 times 2 will be 4. We put our bracket, and our limits are from minus 2 to 0. So when you substitute x for that is start with 0 for x, since we have x to power 4 divided by 8, that will be 0. The second term will also be 0, and the third term will be 0. So we can say that when you substitute x for 0, you get 0. The other one is you get this is equals to, you put the bracket, you substitute minus 2 So this is minus 2 into bracket squared divide this is to power 4 divide by 8, and then we have minus, this is x, this is cubed, x cubed, we have minus 2 cubed divide by 6, and then we have plus this is minus 2 divide by 4, and this is to power 2. So when you compute this, you get the area will give you minus 5 and 2 over 3. The minus sign is because the area is under or below the x-axis, and therefore we say that our area is 5 and 2 over 3 square units. So that is the first part. The other one is part B. We have area is equals to the integral. This area starts from 0 to 3. So our limits are from 0 to 3. The same function, that is x to power 3 divided by 2 minus x squared divided by 2 plus x square x to power x divided by 2. So this is with respect to x. So when you integrate this, you get x to power 4 divided by 8, then minus x cubed divided by 6, that is 2 multiplied by 3, and then plus x, this is x squared divided by 2 divided by 4, that is 2 times 2, and our limits are from 0 to 3. So when you substitute, you get area is equals to, this will be 3 to power 4 divided by 8 minus 3 cubed divided by 6 plus 3 squared divided by 4, close a bracket. The other one is 0 because when you substitute each and every term, you end up with 0. And when you compute this, you get that the area is 153 divided by 8. Now this is the first area, and this is the first area, this is the second area, and therefore we say that total area is equals to A plus B, which is equals to, when you add 5 and 2 that, you add to 153 over 8, you get 9, 1 over 8, that will give you 24, 19 over 24. So that is the total area that is shaded in our diagram. So that is how you go about it. So when you have an area that is a mixture of an area, which one of it is under or below the x-axis and the other one is above the x-axis, then you need to work out individual areas and you total them. This is because, as you can see here, this area was negative, this area we got negative. So if you were to use this negative and this one, you get the wrong area. So that is very important. To get complete DVD of this topic and other topic, call us on 0725 35 7594. So in this example, we are required to find the area shaded. Now here we have two graphs, y is equals to a half x, and another quadratic graph, y is equals to 4x minus x squared. We get the area by integrating, but we need to find the limit. The two graphs share a common point A. So this is where we can put our point A is. So at point A, y of this function is the same as y of this function, and therefore we can equate them. So a half x is the same as 4x minus x squared. So when you work out this, you find that x is equals to 0 or 3.5. This means that this point here is 3.5, and of course here we have 0. Once we find that point, then we can get the shaded area by integrating the function y is equals to 4x minus x squared, and we minus the area under the curve y is equals to a half x up to 3.5, which forms a triangle. So area is equals to the integral from 0 to 3.5 of 4x minus x squared with respect to x. We minus the area under the graph y is equals to a half x, so we have a half x, and the lower limit is 0 and the upper limit is 3.5. This is with respect to x, or dx. Now when we integrate this, you get here it will be x squared divided by 2, so we end up with 2x squared minus this will be x to power 3 divided by 3, so it is x cubed divided by 3, and our lower limit is 0 and 3.5. We minus, when you subtract this, or when you integrate a half x, you get x squared divided by 4, and the limits are, this is x squared 0 to 3.5. So this will give us is equals to, now when you substitute 3.5 in the place of x and you substitute 0, you subtract, you get this is equals to 24.5. You minus, you substitute 3.5 in place of x squared, and 0, you also do the same to 0, you will be able to get 3.0625. So that means that the area shaded is equals to, when you subtract 24.5, you subtract 3.0625, you get, this is 21.4375 square units. So that is the area which we can also in short write as equals to 21.4 square units, and this is to 1 decimal place. So that is how you get an area given the situation on our graph. So the important thing is, if it is part of the graph that is shaded, then you should know which area to subtract from the other. To get complete DVD of this topic and other topic, call us on 0725 357594. You can advertise here. Just call us on 0725 357594. Thank you. To get complete DVD of this topic and other topic, call us on 0725 357594. This is Teacher Wamtaa Productions. Mobile number appearing on your screen, my email address, and you can visit my YouTube channel Teacher Wamtaa for more topics and revision.